Researchers fed an artificial intelligence system every known ancient Egyptian hieroglyph, thousands of symbols spanning over 5,000 years of history, and asked it to find patterns no human scholar had ever noticed before. What came back left seasoned archaeologists sitting in stunned silence because the machine was not just translating old inscriptions faster than humans, it was finding connections buried inside this ancient writing system that had remained completely invisible to us for over 2 centuries. To understand why this moment matters so much, you have to understand just how difficult hieroglyphs have always been to actually read. For nearly 1,500 years after the last known hieroglyphic inscription was carved, absolutely nobody on Earth could read this script. The knowledge died out completely, buried along with the priests and scribes who once used it every single day. Ancient Egyptian writing became a total mystery, a beautiful but silent code covering temple walls, tombs, and monuments across an entire civilization. That silence was finally broken in the year 1799, when French soldiers stationed in Egypt stumbled upon a broken slab of black stone near the town of Rosetta. That stone, now famously known as the Rosetta Stone, contained the exact same royal decree written in 3 different scripts: ancient hieroglyphs, a simplified Egyptian script called Demotic, and ancient Greek. Because scholars could already read Greek fluently, they finally had a starting point, a kind of ancient bilingual dictionary carved directly into stone. Even with that incredible head start, it still took brilliant scholars more than 2 decades of painstaking work to finally crack the code. A French linguist named Jean-François Champollion is widely credited with the breakthrough in 1822, after years of comparing symbols, testing theories, and slowly building an understanding of how this complex writing system actually functioned. For the next 200 years, the study of hieroglyphs remained an extraordinarily specialized, slow, and painstaking discipline, requiring years of intense human training just to become moderately proficient at reading ancient texts. Here is what most people do not realize about hieroglyphs, the thing that makes them so fiendishly difficult even for trained experts today. This was never simply a straightforward alphabet where one symbol equals one sound. Hieroglyphic writing mixed several completely different systems together at once. Some symbols represented actual sounds, similar to letters in our alphabet. Other symbols represented entire words or ideas directly, almost like tiny pictures standing in for complete concepts. And to make things even more complicated, many inscriptions leave out certain sounds entirely, expecting the reader to already understand context, grammar, and vocabulary well enough to fill in the gaps themselves. This is precisely the kind of fantastically complicated puzzle that modern artificial intelligence turns out to be remarkably well suited for solving. Unlike a human scholar who might spend an entire career specializing in inscriptions from just one specific era or one particular region of Egypt, an AI system can be trained on virtually every surviving hieroglyphic text simultaneously, drawing on temple inscriptions, tomb paintings, papyrus scrolls, and administrative records spanning thousands of years all at once. Researchers working on this exact challenge have spent the past several years building increasingly sophisticated machine learning models specifically designed to read and translate hieroglyphic text. One major research effort, sometimes described using the term hieroglyphic transformer, applied the same kind of deep learning architecture that powers modern large language models, but trained it specifically on the grammar, vocabulary, and symbol patterns unique to ancient Egyptian writing. Other research teams have built specialized computer vision systems capable of automatically identifying and classifying individual hieroglyphic symbols directly from photographs of weathered, damaged, or partially eroded stone inscriptions, something that used to require an expert human eye and years of specialized training. Google's own research lab even released a public tool called Fabricius several years ago, designed specifically to help both professional Egyptologists and curious members of the public begin learning and even translating basic hieroglyphic symbols, using machine learning models trained on thousands of confirmed examples. The team behind that project described hieroglyphs in a way that makes them instantly easier to understand for modern audiences, comparing this ancient writing system to something we already use constantly today: emoji-style symbols that visually represent both sounds and entire ideas at the same time. If you find it fascinating how modern technology keeps unlocking secrets from civilizations thousands of years old, go ahead and hit that like button right now. It genuinely helps this channel keep bringing you deep dives exactly like this one. Now here is where things start getting genuinely remarkable. When researchers feed massive AI systems this incredible volume of hieroglyphic text all at once, patterns start emerging that individual human scholars, no matter how brilliant or dedicated, would likely never notice working alone. A human Egyptologist might spend their entire career focused on texts from just one specific dynasty or one particular temple complex. An AI system trained across the full breadth of surviving hieroglyphic material can instantly compare grammar patterns, symbol usage, and phrasing choices across completely different eras separated by hundreds or even thousands of years. This matters enormously because ancient Egyptian civilization did not remain static or unchanging throughout its incredibly long history. The language itself evolved dramatically over time, shifting through several distinct phases scholars now refer to as Old Egyptian, Middle Egyptian, and Late Egyptian, each with subtly different grammar rules, vocabulary choices, and even different conventions for how certain symbols were used. Tracking exactly how and when these shifts occurred has traditionally required scholars to painstakingly compare huge numbers of individual texts by hand, cross-referencing dates, locations, and known historical events to piece together a coherent timeline. Artificial intelligence models trained on massive hieroglyphic datasets can potentially map out these subtle linguistic shifts far more precisely and far more quickly than human researchers working alone ever could. By analyzing thousands of texts simultaneously, these systems can identify exactly which grammatical patterns first appeared in which regions, how quickly certain phrases spread across different parts of Egypt, and even flag inscriptions that appear to blend features from multiple different time periods, something that might suggest an inscription was carved later than originally assumed, or that certain scribes were deliberately drawing on older, more traditional forms of the language for specific ceremonial or religious purposes. There's also a fascinating practical challenge that AI has proven remarkably useful for solving, something that has quietly plagued Egyptology for decades. An enormous number of hieroglyphic inscriptions surviving today are damaged, weathered, or only partially preserved. Stone erodes, paint fades, sections of temple walls collapse or get deliberately destroyed over the centuries, by later rulers seeking to erase their predecessors from the historical record entirely. This leaves modern researchers staring at frustrating gaps in otherwise readable texts, missing symbols that could dramatically change the entire meaning of an inscription depending on what once filled those empty spaces. Machine learning models trained on massive amounts of complete, undamaged hieroglyphic text can actually make statistically informed predictions about what missing or damaged symbols most likely originally said, based on grammatical, patterns, common phrases, and contextual clues drawn from thousands of similar complete inscriptions. This does not mean the AI is simply guessing randomly. It means the system is drawing on an enormous, comprehensive data set of confirmed hieroglyphic patterns to make genuinely educated predictions, filling gaps that would otherwise leave crucial historical information permanently lost or endlessly debated among human scholars. Beyond just individual symbols and damaged texts, researchers have also begun using artificial intelligence for something even more ambitious, actually helping locate entirely new archaeological sites that human researchers might never have noticed on their own. Teams studying satellite imagery and geographic data across the wider Mesopotamian floodplain region have used AI models to help identify subtle patterns in the landscape that hint at buried ancient settlements, patterns invisible to the human eye but detectable through careful computational analysis of soil composition, vegetation patterns, and subtle variations in terrain elevation. A similarly striking example comes from Peru, where researchers used artificial intelligence to help identify previously unknown Nazca geoglyphs, those enormous ancient line drawings etched into the desert floor depicting humans and animals, visible in their full form only from high above the ground. AI-powered image analysis helped researchers spot faint, previously undiscovered geoglyphs hidden among existing known examples. Geoglyphs that had remained completely unnoticed by human researchers, despite decades of careful study in this exact same region. This pattern keeps repeating itself across archaeology right now, and it reveals something genuinely important about what artificial intelligence actually brings to historical research. It is not necessarily smarter than dedicated human experts in any deep, meaningful sense, but it can process almost unimaginable volumes of data simultaneously, spotting statistical patterns and subtle correlations that would take human researchers literal lifetimes to notice manually, if they ever noticed them at all. Of course, this rapid technological progress comes with important scientific caution attached as well. Researchers studying these AI translation systems have specifically warned about a problem called data contamination, a situation where an AI model might have already been exposed to existing scholarly translations during its training process, essentially allowing it to reproduce established human interpretations, rather than genuinely decoding fresh, original insights entirely on its own. This is an important and honest limitation that serious researchers openly acknowledge, rather than something that gets quietly ignored in pursuit of dramatic headlines. If artificial intelligence unlocking secrets buried inside ancient civilizations is the kind of content that genuinely fascinates you, make sure you are subscribed, because there are countless more incredible discoveries just like this one waiting to be explored right here on this channel. Despite that important scientific caution, the genuine breakthroughs happening in this field remain deeply significant. Consider just how much surviving hieroglyphic material actually exists across the world today. Thousands of papyrus scrolls sit inside museum archives, many only partially translated or not translated at all, simply because there are not nearly enough trained human Egyptologists available worldwide to work through this staggering volume of surviving material. Temple walls across Egypt contain thousands of individual inscriptions, many photographed decades ago but never fully analyzed by human scholars due to limited time, funding, and available specialized expertise. Artificial intelligence offers a genuinely realistic path toward finally working through this overwhelming backlog of unexamined, ancient material. Instead of replacing human Egyptologists entirely, these tools function more like an incredibly powerful research assistant, capable of rapidly scanning, classifying, and drawing initial conclusions from massive amounts of material, allowing human experts to focus their specialized attention on the most interesting, unusual, or scientifically significant findings the AI manages to surface. Think about what this actually means for our understanding of ancient Egyptian civilization moving forward. For 2 centuries, our knowledge of this incredible culture has been built primarily on whichever texts happened to catch the attention of individual human scholars, researchers who could only read through a tiny fraction of all surviving material during their entire working careers. Now, for the very first time in human history, we have tools capable of comprehensively analyzing virtually the entire surviving body of hieroglyphic text simultaneously, potentially uncovering patterns, connections, and historical details that have been sitting quietly in plain sight for literally thousands of years, simply waiting for the right kind of comprehensive analysis to finally reveal them. There is something genuinely moving about this entire process when you really stop to consider it. Ancient Egyptian scribes spent their entire lives carefully carving and painting these intricate symbols, preserving religious beliefs, historical records, personal stories, and even mundane administrative details like tax records and shopping lists for future generations to eventually discover. For over 1,000 years after their civilization eventually faded, that knowledge sat completely silent, utterly unreadable, until human ingenuity finally cracked the code using the Rosetta Stone. And now, 2 centuries later, an entirely new kind of intelligence, built by humans but operating in a fundamentally different way than any individual human mind ever could, is helping us listen to these ancient voices with a level of comprehensive detail that simply was not possible even a single decade ago. We are living through a genuinely remarkable moment in the long history of archaeology and Egyptology combined. The tools available to researchers today allow us to revisit civilizations we thought we already understood fairly well, and discover that there are still entire layers of meaning, connection, and historical nuance waiting patiently to be uncovered. Every hieroglyph carved into ancient stone was originally meant to communicate something important to someone, whether that message was intended for fellow priests, future pharaohs, or simply the gods themselves. Thanks to advances in artificial intelligence, more of those ancient messages than ever before are finally getting the chance to be properly heard again, thousands of years after they were first carefully carved into stone. Let us take a closer look at exactly how these AI systems actually approach the challenge of reading hieroglyphs, because the technical process itself reveals something fascinating about the underlying nature of this ancient writing system. Modern computer vision models begin by scanning photographs or high-resolution scans of inscriptions and breaking them down into individual symbol shapes, similar to how a human eye would visually distinguish one carved image from another. But identifying a symbol visually is only the very first step. The much harder challenge lies in understanding what that symbol actually means within its specific surrounding context, since many hieroglyphic symbols carry multiple possible meanings, depending on which other symbols appear directly beside them. This is where deep learning architecture becomes genuinely powerful. Rather than treating each symbol as an isolated puzzle piece to be solved individually, these transformer-based systems, the same underlying technology that powers many modern language models, are specifically designed to analyze entire sequences of symbols together, weighing how each individual symbol relates to everything surrounding it within the full inscription. This mirrors, in a fascinating way, how a fluent human reader naturally processes an entire sentence at once, rather than laboriously sounding out and interpreting one isolated word at a time. Researchers training these systems face an additional unique challenge that most modern language AI simply never has to deal with. Unlike English, French, or virtually any other widely spoken modern language, there's no living native speaker of ancient Egyptian left anywhere on Earth to consult, double-check translations, or confirm subtle nuances of meaning. Every single training example these AI models learn from comes exclusively from painstaking translations built up over 2 centuries of dedicated human scholarship, meaning the quality and accuracy of these AI systems depends entirely on the depth, consistency, and reliability of that existing body of human research. This dependency creates an interesting and genuinely important feedback loop worth understanding. As these AI models improve and begin generating more confident, more accurate translations, human Egyptologists can use those AI-generated results as a helpful starting point, quickly reviewing and correcting them rather than starting completely from scratch with every new inscription. Each correction human experts make in turn helps improve the next generation of these AI models, creating an ongoing collaborative cycle between human expertise and machine processing power that steadily improves accuracy and coverage over time. It is also worth appreciating just how enormous the sheer volume of undigitized and untranslated hieroglyphic material actually remains, even after 2 full centuries of dedicated scholarly work. Countless papyrus fragments sit carefully preserved inside climate-controlled museum storage facilities scattered across the world, many photographed and cataloged decades ago, but never fully translated, simply due to limited available time and specialized expertise. Entire tomb complexes across Egypt contain wall after wall of inscriptions that have been documented photographically, but never received the kind of deep, dedicated scholarly attention needed to fully understand every subtle detail and hidden nuance they contain. Artificial intelligence offers something genuinely unprecedented in addressing this overwhelming backlog, the ability to systematically work through this staggering volume of material at a scale and speed that would be completely impossible for human researchers working through it manually, one inscription at a time, across multiple human lifetimes combined. This does not diminish the crucial value of human expertise in any way. If anything, it dramatically amplifies what human experts are capable of accomplishing, freeing up their specialized time and attention to focus specifically on the most unusual, ambiguous, or scientifically significant findings that these AI systems manage to surface from otherwise overwhelming volumes of raw material. There's another layer to this story worth genuinely sitting with, something that goes beyond simple translation speed and touches on how we actually understand entire civilizations. When researchers can suddenly compare grammar patterns and symbol usage across thousands of different texts simultaneously, spanning multiple regions and multiple centuries at once, they start noticing broader cultural and historical patterns that were previously buried beneath the sheer, overwhelming scale of available material. Trade relationships between different regions of ancient Egypt might become clearer through subtle shifts in vocabulary usage. Religious practices might reveal previously unnoticed regional variations, hidden differences in how certain gods were described or honored across different temple complexes built centuries apart. Some researchers studying this exact area have also raised an important and genuinely thoughtful concern worth mentioning here as well. As artificial intelligence becomes increasingly central to how we study and interpret ancient texts, there is a real responsibility to ensure these tools remain scientifically rigorous rather than simply impressive sounding. A translation generated confidently by an AI system is not automatically correct, and dedicated human oversight remains absolutely essential for verifying results, particularly for historically significant texts, where getting a translation wrong could meaningfully distort our broader understanding of an entire civilization's beliefs, history, or daily life. This kind of careful, appropriately cautious approach is exactly what separates genuinely valuable scientific progress from empty technological hype. The most credible researchers working in this exact space consistently emphasize that these tools function best as powerful assistants supporting human expertise, rather than complete replacements for the deep, nuanced cultural and historical understanding that dedicated human Egyptologists bring to this work after years of specialized training and immersion in this incredibly rich ancient civilization. And yet, even with all of that appropriate scientific caution firmly in place, the sheer scale of what has already become possible remains genuinely remarkable to consider. We now have systems capable of reading through staggering volumes of ancient text, spotting subtle grammatical evolution across thousands of years, making statistically grounded predictions about damaged or... There is another layer to this story worth genuinely sitting with, something that goes beyond simple translation speed and touches on how we actually understand entire civilizations. When researchers can suddenly compare grammar patterns and symbol usage across thousands of different texts simultaneously, spanning multiple regions and multiple centuries at once, they start noticing broader cultural and historical patterns that were previously buried beneath the sheer, overwhelming scale of available material. Trade relationships between different regions of ancient Egypt might become clearer through subtle shifts in vocabulary usage. Religious practices might reveal previously unnoticed regional variations, hidden differences in how certain gods were described or honored across different temple complexes built centuries apart. Some researchers studying this exact area have also raised an important and genuinely thoughtful concern worth mentioning here as well. As artificial intelligence becomes increasingly central to how we study and interpret ancient texts, there is a real responsibility to ensure these tools remain scientifically rigorous rather than simply